the set of number that is used to describe the position or the energy level of an electron is called quantum number. Please take note. Quantum number is to determine the position or the energy level of an atom. Let me just use electron or electron. So what you use to determine the position or the energy level of any atom or any electron is what we call what? Quantum number. And there are four quantum numbers, four set of quantum numbers. The first one is the principal quantum number, followed by the azimuthal quantum number or the subsidiary quantum number. We call this magnetic quantum number, while the last one is the spin. The spin. Now, generally in chemistry, like what I said in my other videos regarding the periodic table, there is a very sensitive part of the periodic table which is called the share, which is also known as the what? The period. So it's either you call them the share or the period. So the set of quantum number, this is just the simplified part of it. Like what I said, the essence of this whole Guido Academy is to simplify chemistry. So the principal quantum number, which is denoted by the symbol n, it is used to describe the share. It is used to describe the what? The share. And remember, we have 7 shares in the periodic table, 7 shares, which are named the K, the L, M, N, O, P, Q, 1, 2, 3, 4, 5, 6, 7. Yeah, Q. These are the 7 shares in the periodic table. But notwithstanding, there's a general formula in which you can use to get the number of electrons that the share can contain using 2n squared. The value of n, the value of this n here in K is 1, here is 2, here is 3, here is 4, here is 5, here is 6, and here is what? Is 7. So if you are told what is the value of n in K is 1. So if they, what is the value? Look at it. So what is the value of n in K share in the first year is 1. So how many electrons can K share accommodate is different from how many, what's the value of n. So how many electrons can K share accommodate? You use this formula. So anywhere you see and you put 1, 2 times 1 square is equal to what? 2. Because 1 square will give us 1, that will give us 2 here. So here will be 2. So how many electrons can the K share accommodate? 2 times 2 square. 2 square will give us 4. 2 times 4 will give us 8. So here will be 8. Then how many can the M share accommodate? 2 times 3 square. That will give us 2 times 9, which is equal to what? 18. So here will be 18. Why this place will be what? 32. That's how you continue. So please take note of this. This n here will be 1, 2, 3, 4. That's the value of n for the shares. So, but the value of electron can accommodate, you use this formula. So that's to say the principal quantum number explain everything about the what? The share. As simple as that. So let's go to the azimuthal quantum number. Azimuthal quantum number is denoted by this very symbol L, which is L is equal to n minus 1. Let me explain this. Azimuthal quantum number explains the orbital and the shape. The orbital and the shape of the orbital. Let me use that. So as for orbitals, we have the s orbital. There are 4 principal orbitals in chemistry. Like for the shares, we have 7 shares, but for orbital, how many do we have? 4, which is the s, p, d, f. So these are the 4 main orbitals in chemistry. So what azimuthal quantum number does is that it tells us that this particular orbital, this is s, this is p, this is d, this is what? F, based on the value. And on that thing again, for the shape of the orbital, s here is spherical in shape, form of like egg shape. P here is dumbbell, d is a double dumbbell, while f has a complex shape or a diffuse shape. But remember, s stands for sharp, p is principal, d is diffuse, f is what? Fundamental. I'm going to do all this again and again in my other video, but for now, let me just focus on the concept of quantum number. So I repeat, what azimuthal quantum number explains to us is that it tells us about the shape of the orbital and then what kind of orbital is formed. For example, now let's say if the value of n is 1, the value of L will be 0. So here is, let's say here is n, we already agree that this is n value. This is L, 0, 1, 2, 3, 4, 5, 6. So if you are asked, what is the value if the principal number is 4, what is the value of the azimuthal quantum number, or what's the value of L? If this 4, your answer should be 4 minus what? Minus 1. 4 minus 1, it will give you your answer, which is what? Which is 3. As simple as that. So any value you have for principal quantum number, remove 1 from it, subtract it, remove 1 from it, you are going to get your what? Your azimuthal or subsidiary quantum number. Then the next one here is magnetic quantum number, which talks about orientation of electron. How electrons are arranged, their orientation. What kind of orientation do they have? For example, let me show you something. In other words, I can say it talks about degeneracy, talking about sets of quantum number that have the same energy but different orientation in space. So that's what magnetic quantum number explains. So if the value of L, sorry, let me use N. If the value of N is 2, the value of L is 1. Remember, 2 minus 1. Why the value of magnetic quantum number is plus or minus 1. So what this simply means is that you are going to write minus 1, 0, plus 1. So you are moving from minus to positive. Now, let's assume that the value of N here is 3. Here will be 2. Then the value of ms here will be plus or minus what? 2, which is the same thing as minus 2, minus 1, 0, plus 1, and what? Plus 2. While the last one here, which is called the spin, talking about spin quantum number ms, it's also the same thing as s. So it's how you call it ms or s. It talks about filling of the orbital using plus or minus half. So one of the electron is going a clockwise movement, while the other one is going a counterclockwise movement. So that's just everything about about quantum number. We have the principal quantum number, we have the azimuthal quantum number, we have the magnetic quantum number, and the last one we have there is what? Is spin. Principal quantum number is denoted by the symbol N. Here is N, here is M, here is what? ms. Remember the formula to calculate the number of electrons each of the shell can contain. For principal quantum number, for azimuthal quantum number, talk about the shape or the orbital. Then the magnetic quantum number, talk about the orientation of the electron. Then I explained earlier, which is also known as degeneracy. Why spin is talking about how the electron are fed into those orbitals. These are some of the rules that govern, in fact, these are all the rules that govern filling of electron into orbitals. The first one we have there is the Albert principle, followed by the Pauli's exclusive principle. This principle is called the building block principle, followed by the Pauli's exclusive principle. Then the last one we have there is the Hund's rule or the Hund's rule. I don't know how you pronounce it. So for the Albert principle, there's one word I do use, A, B. Pauli's principle, apostrophe. Hund's rule, then they just leave that. So for Pauli, sorry, not apostrophe, for Pauli, Paul and the Lis. Then for the Hund's rule, we use apostrophe. So to me, this is what I used to remember the whole stuff. So if you look at the Albert principle, it talks about A and B. A, B. That's to say, if you have to fill any orbital, so if you want to fill any orbital, it is very, very important you fill the smaller ones first before you fill the higher ones. For example, if you have 1s and then 2s, which of them is higher? Everybody knows that is 2s. The higher the energy level, the lower the stability. So 2s is higher than 1s, but 1s is more stable than what? 2s. In case you are confused, sir, how do you know that 1s is higher, is lower than 2s? You are going to use this formula, n plus L rule. N plus L. What is the value of n here? Is 1. What is the value of s? S is what? Is 0. So what about this one now? Here is 2. S is what? 0. For the previous video, I've already explained that. So what you are going to do here will be what? 1, here will be 2. So this one is more stable than this one, whereby this one has a higher energy level because here is 2. So what about if you have 2p? 2p will now be, here will be 2 plus what is the value of p? Please, in case you are confused, the L value of S, P, D, and F. Here is 0, here is 1, here is 2, and here is what? Is 3. So what is the value of the 2p now? 2. What about the value of p? P is what? Is 1. 2 plus 1 will give us what? 3. So that's for that. But most cases, we always work with 1s, 2s, 3s. Let me stop in 4s. Here will be 2p, 3p. Here is 4p. Here is 3d. Here is 4d, and here is 4f. So we rule like this. There's one formula I do use: 1 1 2 2. So the first arrow must go across 1, second arrow must go across 2, second arrow must go across 1, third arrow must go across 2, fourth arrow must also go across what? 2. So at the end of the OT, you are going to have, if you follow this arrow, you are going to have 1s followed by 2s followed by 2p followed by 3s followed by 3p followed by what? 4s. So this is the electronic configuration for the first 20 elements. So this is the electronic configuration for the first 20 elements. So for our bar principle, it's telling us that before you go to the 2s, make sure you feed the 1s first. Before you go to the 2p, make sure you feed the 1s and the 2s first. Before you go to the 4s, make sure you feed all these orbitals before. So that's just everything about the chemistry. Is more of human. For example, if maybe your dad is about traveling, or your guardian is about traveling, and he dropped, let's imagine he dropped 10,000 with you, and he said he will not be coming for like let's say for like a week, and you know fully well that 10,000 will not be enough for your upkeep and the rest, and you are with a child. As a good now you are going to be the guardian to that child. As a good guardian, what you are expected to do is that make sure that child eats first before yourself. So you are going to feed that child will be stable, then you are not to eat the leftover of that child. Not that you will eat first and then give the rest of the child. No, it doesn't work that way. So chemistry is trying to tell us that the little ones are to be fed. Make sure they are very, very stable, they have eaten before the higher ones are expected to do what? To eat. So for Pauli's exclusive principle, it's talking about no two electrons have the same quantum number. No two electrons. If you want to feel, for example, here is 1s, here is 2s, here is 2p. This particular bus here, okay, let me do something like this first. This particular bus here, if I have 2 electrons, if I have 3 electrons rather, I won't feel 1 2 3. It is wrong. I am to feel this one will be filled up first before I will come to this one here. So that's what the ABBA is trying to tell us. Why for the Paulis is talking about two electrons. You don't have to like fill more than in a particular box. Then for the Horns rule, it explains degeneracy. If you have the p orbital, you see the p orbital has 3 degeneracy. For example, if you want to fill 3 electrons, since it has 3 degeneracy, here is ps, here is py, and here is pz. S orbital has 0 degeneracy, p has 3, d has 5, while f has 14, has 7 rather. So what you have to do is that, let me write s, here is s, here is p, here is d, and here is what? F. 2, 6, 10, 14, 0, 3, 5, and 7. So the number I have at the bottom is the degenerate orbital, while the one I have at the top is the maximum electron it can contain. So if you look at this closely, if I want to fill in 3 electrons, since they have equal energy level, let's say for example your dad bought 3 phones. Let me use that. And they had tendency that one person can get 2. One person can get 2 phones. But as long as all of you have equal energy level, you are triplets, same day, everything almost the same, just the time difference, there is no way one person will get 2, whereby one person will not get. So what will happen is that here will go with 1, go with 1, go with 1. So that's how you fill the 3. As the mate is 4 phones, the 4th one can go for any, since you cannot destroy the phone, the 4th one can go for anybody here. It can be here, it can be here, it can as well be here. So but it is best we put it here since you are dealing with PS, but in the real sense they have equal energy level, so even if you put it there, there's no problem. But what Hunt is trying to say is that make sure you feed them singly, one after the other. Fill it 1 2 3, feed them one after the other before you come back again and start doing your pairing. So if you have any question regarding the whole concept I've explained so far, please feel free to drop that in the comment section. But before you go, I want to ask, 4s and 3d, which of them is more stable? Like what I said earlier, the higher the energy level, the lower the stability. So which of them has the higher energy level? Then which of them is more stable? Is 4s higher than 3d, or 3D is more stable than 4s? Please drop the answer in the comment section. For now, goodbye.